So in this video you created your scans, you clean them and you align them to each other, and right now it's time for merging a model. I already created a video on this topic shortly before the latest version of the EinScan software was available, so you will get some information twice if you already watched it. I'm just doing it again because some of the control panel designs was changing, and don't be confused. It's really better like it had been before. So I just want to show you most important things again. If you have doubts about the effects on the different possibilities that you can adjust, I can as well recommend to look at the previous video from the previous surface version. In this case, the menu have changed. You have everything on the left side, and there is possibility to pre-select a watertight or unwatertight. So we are, like in the last video, start with the watertight model and the auto mode. That means every open area in the object, for example here the marker holes where I didn't dislocate the markers, just for you to remember, if you want to get rid of these marker holes, there is a trick. I don't mind that they are here because for this part it's in the task I'm using that for, it's not needed. Just do your scans and different views and dislocate the markers where they have been, the same amount of markers I recommend, to some place that is for sure not in the previous position of the marker. So you will have in each of the scan that area that is covered in the other scan by a marker, you have it visible for the scanner. So in the end the whole scan setup will contain as well the information of the surfaces. So you can get really rid of all that marker holes that sometimes can lead to some effects like these ones. I was previously closing them, but in the case that you in one setup dislocate the markers to new areas and rescan that areas where the markers had been before and merge it, you will get rid of all that. It's no problem, you will be able to do that easily. So coming back to the real topic of this video, merging different views to a watertight model. So in this case you can choose different qualities of details. I'm going for high quality because I just want in this cast part as well to see the surface and not lose so much information in the first step. Mesh simplification is an algorithm where you are able in some intelligent way to reduce the amount of triangles by curvature based reduction of triangles. That means if you have a flat surface or relatively flat, you don't need many triangles to represent it. In the case that you have a very complex surface, you need a lot of triangles to represent it. Why? Because the triangles itself, they have straight edges connecting the points. That is like in other digitalization processes you have simple linear objects, and by the quantity you create complex shapes, and here it's the same in the triangulation. So we can look at that later on, what it means in some different view. So you can simplify that mesh. That means you will lose some quality but not too much of the information on that part, but you will save a lot of data in this case. The mesh optimization is a process like explained before, that's removing spikes. Spikes are let's say surface effects. You can see them that are looking out of the surface because of reflections that was not able to be eliminated already in the capturing processes. And you can fill marker holes, but this is clear. In the last version, spikes removing was, as I remember, and the optimization included. Tell me if I'm wrong, but I think it was in there. There was no additional checkbox, but right now there is an additional checkbox. So we will look later on the effects of this kind of the regulations or parameters. Remove small floating parts. What I think is really cool, because I don't remember that it was in the previous version like this. And for example, competitor softwares have it already. If there is some small objects that you didn't really delete perfectly from your ground plate or whatever, reflections or things that you didn't want to, you can delete the small objects around this scan. I'm not sure, I think here I didn't leave a noise, I did already cleaned it before, but we can as well play with this later on. And before I talk too much, we will just make the first attempt and see how the result will look like. So the watertight model in auto mode merge is finished, and compared to the previous software version, I got to say it looks really crisp. So I have really nice details regarding the cast surface. I have as well still some not perfect surfaces in high glossy areas, but that's quite normal because of the high glossy problems. And I still have this issue that was in the previous software version, where the auto mode is closing holes not based on boundary curvature. So again, I have here this bulby, not sure if the bulby is really a word, but this bulbing to the inside surface that I don't want. But generally, I got to say, for automatic merging, the result is looking very good. I have sharp inside and outside edges, what is not in all the software solutions in this way the same. Okay, so I'm going to switch to unwatertight, because I don't want this surface effect to happen. And I see right now, like in the video to the previous software version, I have here right now just merged the different views, and there is still some open areas where I or not perfectly scanned the whole surfaces, like here, or there is some areas that were too glossy to be scanned without any kind of the surface treatment. What is here the case? So I am going to in this case manually close that holes. Mark hole filling. Okay. Click apply. and afterwards confirm. And confirm will lead you to the next menu that in the previous version of the software was located on the right side of the screen. Here you got all the mesh operations that you had before and some additional features. So manual filling holes is what we will choose to get this problem avoided. And I can choose each of them and apply, like in the previous video, different kind of strategy. It can be tangent or curvature based. They have all their pros and cons. I was covering that already, so play around and see what you like best of them, and you will see that this kind of the holes filling will avoid in the special rotary areas the problems that you've seen before. And actually I don't need to do it for all the holes, because you've seen there was no major problems in the previous version of the autofill. So I just filled at holes that was not done the way I liked it before, and afterwards I can go to autofill, choose curvature based or tangent or flat, whatever I prefer. And these areas where I didn't like the result so much will be fine. Okay, that was going wrong. I got to say apply, because confirm just says okay, I'm going to accept the current state, but as I didn't choose it, it wasn't filled. You see that there is still some holes open, and why is it? Because here is some length parameter that gives you the limit of the holes that will be filled. So for example, if you have a small hole but with a lot of boundary length, you have to increase that value here to be sure that this is closed. There is given some range that is possible in this parameter. Let's see if I just can increase it. Yes, so I go up to some bigger value where it's all there, but I can see here that in this special case it's worth at least to manually close the bigger holes with the bigger problems, to be sure that they will be filled the way you like it. So it's just some try and error case for you to find out what is the best way to do it. And I can fill them like this. I think in this case maybe flat will look better. Control Z in this case is going to get your choice back, so you don't have to leave the menu. I just click flat in this case. So for me this looks fine. Here flat will lead to some, as it's not a flat surface originally, it will lead to some kind of the less good looking result. There is some irregularities in the surface, but it seems to be a problem of that irregular boundary, so it will not be just resolved by choosing a different algorithms. Actually, you see that results don't vary so much for this special case because the inside of the surface is very much influenced by that algorithm. Sorry, by the boundary. Okay. Anyway, you've seen that there is possibilities to get better results. This was closed by auto functions, and you see that this inside was closed by manual choice of the boundary, and here I can see that this is already as well a lot better compared to the bulbing surfaces I had before. Of course, I can go here and smoothen that surface, but in this case maybe mesh optimization can be done as well. So as I told you, mesh optimization will clean out peaks in the surface more than let's say surface changes that have a smaller curvature change. So just as I recommended already in the video to the previous software version, play with that parameters by putting them to extremes and see what is the influence on the result. So you can see that here surface is in the depression, has lost a bit of the patina, or let's say sandblast finish. Let's go back. And apply. I already have that applied, so I got to go out of the menu. And you are back in the previous version, how it looked before. If you are not sure about the changes in some special area, just screenshot yourself the image of the situation before. Then go, in this case we can go for smoothening. It doesn't really make a difference for which version of the mesh optimization tools you are applying this method. Apply it. And yeah, there's the windows left and windows right. This is not here working. Okay, in this program. Anyway, I'm able to compare the results in the situation before and afterwards on the surface, so I can decide if the result is going the way I want, or if it's too radical or whatever I had as intention. I have a good comparison what happened then. There is different views you can choose, orientations, but they make just sense if you created some coordinate system. Small floating parts to apply it at first to be able to choose new functions. So right now the preview okay, so small floating parts, I think we don't have them here anymore. It was deleted, that means but there's a really big boundary that we lost. So auto holes filling, apply. And with confirm I'm coming out of this. So auto holes filling. That would be really cool if there is like as well a fill all holes command, but because I have to always type here in a value, I can go here bigger to a really big value, maximum for example, and be sure that I get everything that's smaller in the boundary length. But it would be cool if there will be in some of the next revisions some option to choose that says okay, everything that's still open to be filled. Because okay, in this case I recommend you, if you do it like I did, start with the manual hose filling to close problematic areas, and afterwards go to the auto hose filling, type in there a very big value. In most of the modal cases it will be fine. In some of the modal cases it can happen that you have for example boundaries over one hole here in the edges or so, and that would be closed all of that, but I think it will be normally not the case. In most of the reasons, sorry, in most of the cases it will be enough to put here in a big value and that's it. Okay, confirm. We did it already, so texture is not available in this case, and that's quite all that I'm going to do here. And yeah, right now we created a watertight model that you could use in other softwares for reverse engineering, or directly print it on your 3D printer. I hope that you enjoyed the video. I will do, if there is demand for it and you're interested, I will do one video based on texture models with a bit different kind of the background, and yeah, would be happy that you join me.